Welcome to School Report, a glimpse into the classrooms of St. Lucie County Public Schools. School Report provides the opportunity to share with the community academic and extracurricular activities of students in our schools. And now, here is School Report.
Hi, my name is Leslie Taylor, and I wanted to welcome you to the Sam Gaines Academy Science Expo. And this is a culmination of a huge collaborative effort between myself and many of the science teachers here on campus. We decided to do something different for a review or a crunch leading up into the Science FCAT this year for 5th grade and 8th grade. So we attacked it from a different angle. Each of the students will come in and they have a prescription as to which station they're going to go to. We have 8 stations set up for 5th grade. We have 8 stations set up for 8th grade. And we also have 2 stations, one for 5th, one for 8th, for the students who are actually performing well and need some enrichment. So we're expanding their scientific knowledge in a different way as well. We use data from our ClassWorks mini-bats. We use data from our pretest. We use data from our comprehensives from the district level, so this is all data-based, and we've chosen the heavy-hitting standards that we know are through trends from the Science FCAT. Students get asked multiple questions regarding these particular standards, and some of them we know students historically don't perform as well as they should, so we figured this would be a good opportunity for them to review. The premise for all the stations is a hands-on activity. They're very short, they're 20 minutes. Teachers are leading them, as well as some community business partners. So we have people here from the Savannah's Preserve in Port St. Lucie. We have a couple scientists here from the United States Department of Agriculture up in Fort Pierce. And we have a representative from the South Florida Water Management District. And we have some district personnel that are helping us out as well. Hi, this is Terry Barenborg from the district office, and this is also Paul Reef, and the two of them have been invited to come to Sam Gaines Academy to actually work with our students who are in need of enrichment by doing a STEM design challenge. And I'm going to let each of them explain it to you. Terry?
Okay, so the STEM design challenge that we chose for today is Feed the Chimps, which is kind of fun. We're taking the sanctuary for Feed the Chimps, and we are giving it a little twist, and we're giving the kids a scenario. And the scenario is they have to learn how to figure out what to design in order to feed the chimps onto their island without going out on their island, and yet the chimps aren't going to come into them. So how are they going to get the food to go all the way out onto their island? And so today we're going to give them some materials and things to be able to see if they can problem solve and get that challenge done. This is called an enrichment, which is ironic because, say, the chimps, they give the chimps enrichments, and the enrichments they give them is to kind of make them think a little bit more, problem solve, and challenge them. And that's what we're going to do with the kids today, too.
Excellent. And Terry's going to be working with the 5th grade group, and Paul's going to be working with the 8th grade group.
In the 8th grade group, and as well as the 5th grade group, we're going to design catapults to get food from one side of the land to the island. One thing that's very unique about chimps, they can't swim. So they can't get their own food, so food has to be brought to them. And one part of this is we have a chimpanzee who has some, for lack of a better term, emotional issues, who cannot deal with humans. So when he sees a human, he attacks a human. So we need to feed that chimp. So we need to get the food from the mainland onto the island, and the students are going to design a catapult to assure that the chimp gets fed properly.
Thank you. Thank you both for being here.
Sure.
Our pleasure.
I just wanted to introduce Marjorie Laster. She is an instructional partner at the district office, and her specialty is elementary science. So I'm going to have her explain what her station is about.
Well, we are letting the students explore circuits and how to make a complete circuit and get a light bulb light. And then they will actually as well get to install switches into their circuit and practice with open and closed switches, as well as adding motorized components as well. And then also getting to test different objects to see whether or not they are good conductors.
Thanks for being here.
So I just wanted to add that this is the preview before the expo actually begins. And once it starts, the interviews with the actual teachers is going to be difficult because they're all going to be at a station and the kids are going to be rotating at a pretty rapid pace. So I'm just highlighting a few off-campus individuals that have come to help us, but really the work that's been done every single day with these children is in the classroom, and you'll get an opportunity to see those teachers in action today.
I saw in Mr. McKenzie's class today that you guys were learning about the carbon cycle. Is that correct?
Yes.
Somebody tell me something that you learned about carbon. Yes, sir. Okay. Okay, so it's a cycle, and it goes in the atmosphere, in the ground, through living organisms. Like, it's never ending, right? That's what a cycle is. So that particular cycle is directly, it's supported by the law of conservation of mass and energy. And I know that you guys learned about that at the beginning of the year when you were learning about chemistry. Does anybody remember the laws? What can happen to energy?
It can be changed or transformed.
It can be changed or transformed.
But it cannot be destroyed.
It cannot be destroyed or created. Do you guys remember? Okay. So I set up this demonstration to show you. This is yeast, and I threw in some sugar, and it's just warm water. You can touch it. It's just warm because the warmth activates the yeast because yeast is a living organism. So because it's a living organism, it has to respire or breathe just like we do. And I have the chemical equation up here for cellular respiration. So all organisms have to take in oxygen and they convert it into usable energy. Well, the balloon is sucked in. Does anybody know why the balloon is sucked into the beaker? Tell me your name. Tyler. Tyler, why do you think?
Because the yeast and the liquid are being mixed, and when it mixes, it gives it like collecting all the air that's inside of it.
Okay, so what part of the air is it collecting?
Energy. It's already inside.
What part of the air? Like
Oxygen.
oxygen, okay? So because it's using all the usable oxygen that it can, because this is a closed system, the balloon is sucked in. Does anybody know what the waste is that organisms give off when they breathe? Say it louder.
Carbon dioxide.
So what do you think is going to happen when the yeast start to actually give off carbon dioxide? What do you think is going to happen to the balloon?
It's going to blow up.
It's going to expand. It's going to pop out of the beaker and it's going to expand. Okay? Hopefully by the time you guys make your rounders, it'll be doing that. Because these yeast right now are eating all the sugar that's in there.
Formed, and that's how Earth has changed over time. So scientists didn't figure that out all at once, though. It was a lot of different theories that worked up to that. So we want to read all of these different theories or pieces of the theory and put it together. How do we figure out what came first? So for example, the Navy used sonar to map the ocean floor. That's probably not the very first thing that happened because the Navy's only relatively new. It's only a couple hundred years old, right? So we know that that is probably not the first one.
Oh,
This one is for the tail. Who wants to do that one? Who wants to do the tail? Want to do the tail? Come on. Here you go. All right, so this is mom and this is dad. All right, so watch what he does.
And that's your 1 minute. Okay? 30 seconds. And that's why you use this.
All right, help him out. First thought. All right. So what are the possible genotypes out of this cross?
Is this yours? Oh, sorry. No, wait.
What is it? Big C, little c. Write that down. And little c, little c. All right, so those are the possible genotypes. What are the possible phenotypes? Look at the key. Curly tail?
No, no, no.
And?
It's just like, no, because you have a big C and a little C.
And that's a what? That's heterozygous for dominant. And then he also has a little C and a little C in that cross, which could be what? Or a straight tail. So the baby can either have a curly tail or a straight tail. Excellent. Thank you so much. Make sure you write that down on your...
You pose the timer while I'm doing the jumping jacks, and then once I get done, restart the timer, check my pulse rate, and then start the timer again, check my pulse rate. Ready?
So, Mr. McKenzie, what do I get?
Okay, so then what you're going to do is that for a minute, or for 10 seconds, multiply that by 6. Because a minute is 60 seconds, right? You're doing it for 10 seconds, that's 1/6. You're going to multiply the rest of it by 6. 16 times 6. Duration of activity, this is 30 seconds. Okay. All right, did you gentlemen do your jumping jacks? You do it first. All right, then you guys, one of you's got to do it, and the other one's got to time you for 30 seconds. So you do yours now for 30 seconds, and then you guys switch, okay? And then check your pulse. All right?
All right, so right now, you're going to roll down the dice, and you're going to record by your seconds, and it's a trial. Do everyone understand? All right, go ahead. Make sure that you record it on your sheet. Do we have one more trial?
What was 1,001 or trial?
What was it? Do you have a Pedro?
Second.
You have here?
29.
And
where was next to the number?
so do we have to do it one more time because we need to add all of them together, and then we're going to divide it by 3. Get a calculator, Caleb, and add them up and divide it by 3. Push them up. All right, so you're good. 8.6 for your average of trials for trial 1. You ready?
Y'all ready?
All right, and then you do so far, so
Wait
far.
until she says 1,001. Go. Start over. Somebody count 1,001. Get it. So we're going to start over. Okay? That was a practice. Again, marble at the top of the ramp. You got to count loud enough so that they can hear you. She says 1,001. Ladies, as she says 1,001, I need you to mark the spot. Okay? Wherever the marble is. When she says 1,002, I need you to mark the spot. When she says 1,003, mark the spot. Okay? Keep your finger there wherever the marble is. Don't put your finger there yet because you don't know where it's going to be. Put your finger. 1,002. So in here, right? Keep your fingers there.
The North Pole on the globe. Here's the South Pole at the bottom. You have that on your paper, right here? Okay. The next step is, where's the equator?
The equator is on that.
Show me on the globe. Good. So it's the middle of, it's the middle. It's a line. 0. Okay? It's the center. What does it separate? What does the equator separate?
It separates the southern half, the northern hemisphere and the southern.
Very good. Did you guys hear that? What does the equator separate? Northern hemisphere and southern hemisphere. Very good. I'm sorry, I'm having you repeat just because it's loud in here, so I want to make sure you guys hear me. Northern hemisphere, southern hemisphere. Good. So, show me again how this looks on one day. Show me one day.
Wouldn't be as fast.
No. Okay? identified the North Pole, Equator, South Pole, Southern Hemisphere, North Hemisphere. Show me where Earth's axis is on this picture. It's an imaginary line going straight through. So if we could imagine what this would look like if it was clear, it would be a pole from this dot all the way to the bottom, okay? So that's the axis. So basically it's spinning on that axis. Okay. All right. Let's look at the next one. We went through all these steps already. Let's look at the next picture on the next page. All right. So you have your sun. And you can go back to your picture on the front page if you need to. Which one of these Earths that is rotating around the sun, which one is showing where northern hemisphere is having summer? Which one of these?
This one.
How do you know?
Because the northern hemisphere is tilted towards the sun.
Okay. Do you all agree? He's saying the one on the right-hand side is summer for northern hemisphere. Do you agree or disagree? How many people agree? Put your thumbs up if you agree. Agree? Perfect. That is summer. So on that one, you're going to write northern hemisphere and the southern hemisphere. Identify those two things. And then put summer for us, because we want to know what it is for us. Where is it winter?
Fractions first. On the top of the chart. Fill the bowl with ice.
Observe, answer the question on the paper. Clean your area.
Okay, so we're gonna make it rain today. So we're gonna see some parts of the water cycle. But first, let's put on our gloves. Okay. I don't think there's enough for everybody, so just wear one, please, so everybody can get one. I said just wear one, so everybody can get one. Okay, put it in your hand that you grab everything. Okay, you have one, Kiara?
Yeah.
Okay, perfect. Now everybody needs a mason jar
Around here.
and a paper plate.
You're going to need a little bit of space here, okay? Oh, I already have them setting out. There's one right there.
Yeah. You two have. So Kiara, you need a mason jar. Here you go. Okay, so guys, I'm gonna do this part because this is hot. Okay, so when you get it, please be careful. Okay.
There's soup in there or something?
As soon as you get it, put the paper plate on top so you can trap.
I'm gonna trap.
Like this, honey.
Only touch the jar with the hand with the glove on it. You have the glove to protect your hand from the heat. So if you're going to touch the jar, use the glove.
And start observing what is happening so far.
Just start observing. Start looking at your jar.
Thank you. Put the paper plate, Jose. Put the paper plate. Careful, it's really hot.
I'm making it.
Skating, how do you call it? Breathe.
Okay, stop observing what is happening so far.
The top of the bottom.
No, look, observe. Go down, go down. Stop observe, what is happening?
It's getting like foggy. It's
And
evaporating.
what is foggy? What does that mean?
Evaporating.
Evaporating, do you think?
Yes.
So when liquid turns to water vapor, that is what? When liquid turns to water vapor is?
Condensation. Evaporation.
Evaporation, very good. So we're trapping what right here? What we're trapping in there? Water. Water what? Remember what's humidity? What's humidity again, Kiara? You remember? I know you like that one. What's humidity? The amount of what?
About the space.
The amount of water vapor in the air. So we're trapping what right here? Water vapor. We're trapping water vapor. So what you see right here is what? Water vapor. Right, Jose? We're trapping what? Water vapor. Now,
The part of the water cycle, there's another step that we're gonna make today, and it's condensation. Now, what do we need to turn water vapor to liquid? Our water, to evaporation, we need the water to what? To heat up and turn into water vapor. So what needs to happen to turn the water vapor to liquid? The warm air needs to meet something to turn to liquid. What happens? No, it's condensation. But we need cool air to turn it to liquid. To turn water vapor to liquid, we need cold air. But we don't have cold air, but we do have ice. So I'm gonna dump each and every one of you ice, and we're gonna see what happens, okay?
A smaller amount of ice condense or faster.
That was a windy day. The wind pushed it. Isn't that cool? And what about these fluffy ones? What are those gonna do?
Oh, they can fly too.
Hey guys. Here. You don't want to put the fluffy ones in the water though. When your hands are dry, come see me and we'll do these, okay? Don't forget the ramp. Uh-oh. We might bump into you with seeds. Don't forget the ramp. You can put your seeds at the top and see how far it rolls. Okay? And see how far they roll. See how far they fly. Really? Oh, Daddy, really?
Oh, dang.
It
Got in
hit
the
the
way.
camera.
It hit the camera, so that didn't count. I gotta put it here.
Don't push it. Don't push it.
I'm trying to.
Dash it. Whoa.
Where's the
I think that one wins. Lexus, you want to travel? Whee! But that one you put down on its edge. There you go. There's a good roller.
Abigail, you know where the cup's at? Can you get that right there? See if it rolls. Roll.
Oh.
Oh no! Ah! Roll. Dash and get that right there. Oh no!
Good job.
Woo! Oh, wait, hold that up.
What did you draw a quick little fast picture of one of your seeds, and then what did it do? How did it travel? Okay? You guys, are y'all understanding how to do your data sheet?
Yes.
No? Okay.
No, wait, how do you do it?
Here you go. You're going to do a really fast sketch. Don't try to be artist. This is just a fast little sketch of a seed. And then you're going to come across and say, did it stick to fur? You can just say yes. How far did it roll? Or did it just, you didn't have to do inches or centimeters. You can just say, yes, it rolled good, or no, it didn't roll good. And each of those did it fur. So you have 4 different seeds you can choose from. Okay?
What do we do at the bottom?
Let's see. Base orders, how do you think you should receive dispersed from your parent plant? So you're kind of, in other words, if it's stuck to fur, and sometimes you'll find that you'll do the test and it will float, and it will stick to fur, and it might do something else. But looking at it, when I want you to think about the structures and the test that you put it through, what do you think is the best, most likely way your 4 seeds that you choose out of those 10, how do you think it disperses from or travels from its parent plant? If it sticks to fur really good, probably it's probably not right? If it's a major floater, like floats like a little boat, and it feels like it's a really like a little boat, probably it probably be like that. Okay? Use your best judgment now.
Think it's going to happen? Do you think our temperatures are going to keep going up and up and up? Who said that? Who said that? They're going to do what? Exactly. You guys are exactly right. Our graph will eventually, it'll go up, and then it'll start going back down, right? So let's finish graphing our graph. So for April, where are we going to be? At 23.8. Is 23.8 on our number line, on our numbers? Yeah, so it's not on there, so we have to find a spot between what 2 numbers? I'm sorry? That's okay. 20 and 24. You were looking at the one underneath it. then you can keep going if you would like, if you feel comfortable with, go ahead and grab the next month and then the next month. So does April, up to April, does yours look like mine? Does it look very close to mine? Does it look like it's going up and up and up?
So we can eat or catch.
So take a minute and finish up the rest of the month. Can you do, can you do May? Graph May. What number are you looking for May? 29.3. Again, is there 29.3? Nope, so we have
28 and 32.
yeah, so we have to pick our number between 28 and 32.
So you might actually have to get up and move down and just test each of the 10 vials there and fill out your sources.
You guys are going to have to get up and move then. And you have to test all of that.
It's not banana. You can have 2 bananas in the same one.
In the same tray, yes.
Yeah, they're either going to smell like banana or they're going to smell like
Number 8. This smells so good. I don't like smelling
So
stuff.
go ahead and make sure that you smell all 10 vials.
You guys only have a couple minutes.
Can I get one more? 8 is banana. 1.
Okay, teachers. I'm Miss Colvin. I am one of the guidance counselors here at Sam Gaines. And we have some 8th grade gentlemen here who were able to make a catapult. And this one is called the Mexican Cannon. Gentlemen, this is Daniel. Hello, Daniel. How are you?
Good.
Okay. I want you to explain your Mexican cannon here. You can hold the mic.
Well, what we did here was we put 2 of the sticks and taped them together and put a hole on the cardboard so it could hold. And we did the same thing on another side. And then we put a rubber band between them, and we taped this rubber band on the bottom. And then we put the spoon, we did a hole there, and then we put the spoon there and we taped it, and that's how it works.
Okay. Awesome. Thank you. Can you give us an example of what happens when you release that rubber band? Awesome. Mexican cannon. Thank you. So we are here with Brian. Brian is going to explain how his team built their catapult.
Use tape, some popsicles, and some thingies, whatever, pipe cleaners, and we just stick the spoon inside, and then we just put the thing right here, and then we just go right here, and then, boom, voila. We're gonna win.
Awesome. We have a confident group here. Thank you. Hello. We are here with 3 beautiful 8th grade girls. We have Bree, we have Juanita, and we have Joanna. Juanita and Joanna are going to explain their catapult.
So we have the little pipe cleaners holding the little spoons because it's like we don't put it. They'll like basically come together, and we use the rubber bands to, like, when we go back, it basically gives force to it. Yeah.
We should test it out. Let's see. Go ahead, Joanna. We get a visual here in action. Great. Don't hit your principal with. Thank you. Hello, we have another Catapult group here, again, 8th grade. We have my friend Savine here, who is going to explain how their Catapult works and how they built it.
We made a slingshot, and how it's gonna work is we're gonna cut the blue string, and the weight of the glue is gonna shoot it up in the air.
Okay, I should probably move. Awesome. Thank you. Great job, team. Hello, we have another 8th grade girls group. We have Corinne, we have Jacqueline, and we have Edwindy. And Corinne is going to explain how they built their catapult.
Okay, so our catapult, we basically already had a general design. I know that back when they had catapults in a long time, they had something to stop it where it goes up. So that was our main priority for it first. We had a little trouble trying to balance it out, and we taped the rubber band to the spoon on that side, so when we let it go, it had enough strength to pull it up. We used a lot of tape to have everything held down so that nothing would fall apart when the force of the spoon went down to pull it up. And we used these 2 sticks to elevate the platform a little bit so the ball would go farther.
Awesome. And who would like to do the honors of testing out your catapult? Go ahead, Corinne. Well done, ladies.
The object of this lesson is to have designed a catapult to fling or use force to send this the furthest distance. So this is group A. Ready?